Alright guys, you need to open your notebook to page 62. We're going to be doing 7.3 triangle inequalities. Now, we'll go ahead and tell you that we are going to be doing two parts to this. So you're going to go ahead and label 62 and 63, but we won't finish triangle inequalities today. We'll finish tomorrow. Once you have the title written, you're going to tear some pages out of your textbook, so there's no foldable today. Okay, so you need to tear out 342 and 343. Tear those two out, and we're going to start cutting from them. From 342, you need the triangle inequality theorem. That's all you need from that page. 342, you need the triangle inequality theorem. From 343, you need something from the front and the back. You need example 1, letter A and B, from the front, 343. Okay, and from the back, you need A and B. And it won't fit, A and B on the other one won't fit on that page, but we're not going to page 63. 63 will be full. So we'll hang it off, and then we'll actually cut it. So let me show you what that full piece looks like. Here's what else you need. Okay, we've got these three pieces. We're going to glue them in as we come to them. So that's all you need to cut out. If you need to pause the video and go back and see what you need to cut out, do that. I'm going to have to get a new glue stick. Yep. Glue in the triangle inequality theorem first. We're going to glue this one in. I just can't hold on to a glue stick, evidently. Alright, so let's talk about the triangle inequality theorem first. We'll talk about something else tomorrow. The triangle inequality theorem says the sum of any two sides of a triangle is greater than the third side length. Meaning, if you add two side lengths, the sum of these has to be greater than the third. No matter which two you choose, adding them together has to be bigger than the third side. If it is not bigger, it cannot physically make a triangle. Meaning, if we had like 4, 2, and these touched, but let's think of something smaller than 4 plus 2, 1. Well, guess what? That's not going to reach all the way. It's not possibly going to make a triangle. That's what it's talking about. So, let's look at the first example. And they've actually done one for us. We're going to have to check to make sure whether they actually add up or not. So, in this first one here, 4, 8, and 10. To find out if they do, we're going to have to add 4 plus 8. Is 4 plus 8 greater than 10? Well, it's 12, so yes, so that side works. Then we go to the next one. What about 4 plus 10? Well, 4 plus 10 is greater than 8, so that's fine. 8 plus 10. Is 8 plus 10 greater than 4? Yes. That means the sum of the pair of the side is greater than the third, so this can be a triangle. Okay? So we're going to try the next one. 7 and 9. 7 plus 7, 9, 18. 7 plus 9 is 18. Is 18 greater than 18? No. I could stop right here because one of them is not greater. Now I'm going to go through and show you the rest of them, but I don't have to. The second you have one of them that's wrong, you're done. All right, 9. 7 plus 18. 7 plus 18 is 25. 25 is greater than 9. Doesn't matter, though. Okay, then 9 plus, we've already done 7, so 9 plus 18, is that greater than 7? Since 18 is greater than 7, of course it is, but 9 plus 18 is 27. 27 is greater than 7. That's all well and good, but if I have one that is not greater, it cannot. A triangle cannot have side lengths of 7, 9, and 18. Not going to happen. As soon as one of them doesn't work, it doesn't work. Doesn't matter if it's or equal to, it said greater. All right, we're going to work on these now. We're still using the triangle sum theorem, inequality theorem. I just can't glue it in yet because I don't have enough room, actually. All right, so letter A says, find the possible values for the length of the third side using the same theorem, the triangle inequality theorem. So we're doing the same thing. We're going to be setting up our inequalities. X plus, the side length's x plus 10 needs to be greater than 12, so we found that. X plus 2, okay, great. Then we set up the next set. X plus 12 has to be greater than 10. I'm a negative. You cannot have a negative side length, so we're going to get rid of that one. Okay. 10 plus 12 has to be greater than x, so 22 has to be greater than x. X stands for the third side. The triangle inequality theorem, when you use it to find a side length, you are going to be finding a range of values. You're going to be finding the range of the small number compared to that larger number. So x, the side length, has to be less than 22, but x has to be greater than 2. You write it like this. It is read as 2 is less than x, less than 22. Let's do the next one. Letter B. We have 3 sides. Let's just start with x. X plus 15 has to be greater than 15. Okay, I went this way. Now let's go here. 15 plus 15 has to be greater than x. Okay, so I've done it like this. I've done it like this. Now let's start here. 15 plus x has to be greater than 15. And all the way around. X plus 15, I'm going to move the 15 over. X has to be greater than 0. Okay, that makes sense. Our side length has to be greater than 0. 15 plus 15 is 30. 30 has to be greater than x, meaning that the side length has to be less than 30. Okay, move this over. X is greater than 0. I don't have a negative to ignore, but I do have this twice, so I'm only going to need it once. I'm going to put 0 is less than x is less than 30. So today, you are deciding if 3 side lengths could form a triangle by using the triangle inequality theorem and finding possible missing pieces. It will be a compound inequality. You're going to take this, you're going to glue it in down here at the bottom of page 62. It is going to hang off, and you're going to fold it up. Tomorrow, we're going to finish the triangle inequality theorem, not theorem. We've done the theorem today. We're going to finish this lesson by talking about side lengths and angle measures. So we'll finish this lesson tomorrow. So go ahead and start on the assignment after you have folded this up and completed that.